To the computer. This is Randy Kirk, and this has been a huge day. I have been all morning long waiting for 12 o'clock in California time because there was going to be this announcement with regard to the Optimus bot. I set up in advance that Scott Walter would come on immediately after the announcement. And so, Scott, thank you for coming on.
Yeah, thank you for having me on so quickly, Randy. So nice to be back again. And we're back to our normal roles. I didn't do the introduction this time.
That's true. That's right. I know. What are you going to do?
And I don't have the lion shirt on either. I get the more appropriate one.
More appropriate stuff. There you go. I should get myself a set, I suppose. All right. So this is Randy Kirk. Hit like, hit subscribe, hit notify, all that jazz. You know what to do because we want to get right into the meat of this one. So, Scott, about 7 months ago, I started this channel. One of the very first videos that I put out very early on was the Tesla bot is coming. It is going to be 100,000, 1,000 of them made this year that will be used in factory. They'll be used to train, et cetera, and that they'll make 1 million in 2024. And they'll start selling them or leasing them in 2024. Pretty much got laughed off the street until I had you on my show. And I had you on my show fairly early. I don't know when that was. And we talked about it. And by the end of that show, I think we were in agreement that Tesla bots were coming soon. The Optimus was coming soon. You had a smaller number in terms of how many would be made this year. And then slowly but surely, Tesla Herbert and other folks have come on board. And now we pretty much have a large majority maybe of the people feeling like there are Tesla bots at work and that there are Tesla bots that will be made next year that will definitely be in factories somewhere, but maybe not my million number. I don't think anybody yet is ready to concede the million, and they're not ready to concede that they'll be used, that they'll be leased out to others or to third parties that are not related to Tesla. So those are two things I still need some concession on, neither of which were part of today's reveal,
right?
Connecting the dots. So, Scott, you're the guy, you're the man of the hour. Oh, by the way, is it kind of fun to be chronicling, to be part of the history story of the most important invention maybe since fire?
Yeah, it is. It definitely is. And when you realize that, even being an FSD driver, you're somehow participating in the Tesla bot because it's using the same chip.
Yeah.
So I guess if we want to go back to 7 months, because I think it was maybe around December, January, you were making your first videos.
I was making the first.
At that point, we had not really seen a working Tesla bot of the current generation. They had the original one, and of course they didn't really have anything working in AI Day 1 or AI Day 2 of what was going to eventually be the real Optimus bot. So it was like a leap of faith to think that they even had one that was working at that point. So we're not even sure that they get the one working. And we did see various copies of it kind of traveling around the world, but those look like prototypes. So we really weren't sure what they were going to have. And then it wasn't until Investor Day that we could actually see that there were multiple ones. Because remember, we saw 3 that were actually, 2 that were actually working and the other one that was being assembled. So it's like, okay, we know there's at least 2, and we know they're able to coordinate and kind of work together. And then, of course, by the shareholder day, we get the video where we clearly are seeing 5 in the same room on the same floor operating together. So we could say, we probably have at least 5, and we're probably sure there was more than that because there's probably some others around when you look in the labs and everything else that's been in there. So, probably around that time, it's safe to say that close to a dozen, right around there, you could say, yeah, I bet there's there. So, and then of course, all the speculation we've been doing is like, are the robots doing anything useful at this point? Can the bots actually perform something? And I already went on the record way back, and they say, wait a minute, what they already showed us there is like back last summer, it was already performing tasks which can be done on the shop floor. And we'd already had the discussion about the low-hanging fruit, the real easy task, the Tesla speed video from Shanghai, showing the operator loading these parts in that were very simple. Is Tesla bot's going to do that, and we know it's going to do that because Elon said it was going to do that. He's actually quoted as saying that that's what it's going to do, exactly that task. Elon even said like, oh yeah, after this meeting today, we're going to try to take this version, get it to be as good as the last one and start taking down the factory and doing those things. So we already know they have the roadmap. They're out in Palo Alto. Fremont is nearby. It makes sense. They're going to be going over there and using it in various operations.
And
so
then,
the question is,
and then just to take it back again, for me,
right.
seeing it the very first time. I mean, the very first time that they had the fella come out on stage and kind of do a little dance. That very first time, I'm going as a factory owner for 30 years. I'm going, I could put that guy to work right now. There are things I could use him for in this primitive stage.
Sure.
And how much work could it be to get to the next stage, which is why I made the leap of faith that I did at the time.
Exactly.
And then started calling you and Joe Justice and everybody else, and everybody agreed. This is not a hard task in terms of the hardware. This is where you really came in and said, no, I could assemble this in my garage from off the shelf parts, and it wouldn't take Tesla any time at all. No limiting factors in terms of the motors, in terms of the plastics, in terms of the metallurgy, in terms of the wires and the connector. All of that stuff was easily done and could be put into large production within a reasonable amount of time. A long time.
Yeah. Now the only thing I couldn't do, like in my basement, is make that silicon wafer. That's the hardest part.
Yes.
And of course you can go out and buy some of the various chips that are out there, but then there's that one very special chip, and then of course there's the training that's going on in that, and the dojo and everything you need behind it. So the secret sauce is the AI. Without it, it's just a lump of metal.
Yeah.
Because we have a lot of robots out there that already are able to move around very quickly, do large payloads and stuff like that, have similar degrees of freedom, at least like in one arm. So what's the big deal? And the big deal has always been the software. It's always been able to get the flexibility and to be able to work in an unstructured environment. Industrial robots, it's like an extremely structured environment to make sure it's able to do it and with the kind of repeatability. And everyone keeps on saying, well, wait a minute, if it's such an easy task, why can't they just automate it? And it's like, well, you're almost answering your own question, because it's not as easy as it seems. It's deceptively easy for us humans, but to try to automate it, it just is too hard, and you cannot make the return on investment and the justification for doing it. So the solution is flexibility.
And Tony Seba and Cathie Wood repeat over and over and over again that it's the coming together. I'm forgetting the big word for it, the $5 word.
Convergence. Yeah, the convergence of these technologies.
That's the $5 word. The convergence of technologies. This is what created the iPhone. The iPhone was the result of technology. I can't even get this in my thing here because of my background. Anyway, the iPhone was a convergence of technologies that 5 years or 3 years before, there couldn't have been an iPhone. And the same thing now is true. And quite frankly, from what I'm seeing, without Dojo, it's not possible anyway. Nobody else has the vision language model, the vision language computer that can do what Dojo is doing. Correct.
Now, from the from basically the information that we were able to get from DOTS, and of course there was a little bit of a problem with the lag. Unfortunately, there was like an audio lag and everything else, but we did get some important information. And one is that the bots are already being used in the factory.
Yeah.
Now, whether that means they are actually helping to put together cars yet, or whether they're just going through and demonstrating some of these tasks, but they're down there doing these factory operations.
So the revelation was simply that there are bots working in the factory. Our imagination can run wild, and we can think that they're doing useful tasks that are worth replacing employees right now. Or you guys kind of limited it maybe down to a demonstration, something that the bot is doing that doesn't necessarily replace anybody yet, but could once they turn it loose.
Right. Now, we don't have a fixed number on the bot, so we were already guessing maybe about a dozen, because we've seen 5 at least, and so there's probably a little bit more. He didn't have a fixed number, but said that he was told there are many bots, whatever that could mean, and that some are on the floor, but most are in R&D. So so whatever they have on the floor, and some, that means more than 2, I think. And then if most are on the other, then it's like, well, that most is bigger than the sum. And so you can get something out. So what are we looking at? You know, couple dozen robots. You know, the high end, maybe 100, but maybe they're not quite there yet because maybe they haven't decided they're ready to scale yet. But
Well, on the
um,
but again, let's talk for a minute. Remember our
mhm,
earlier conversations. One of the ways that I try to connect dots, speaking of connecting the
yes,
dots, and again, a big shout out to Dots for putting this together, for doing
yep,
the reporting on the ground. We always need those guys that have those connections and those contacts. But one of the ways that I like to connect dots is by saying, why not? That's
mhm,
one of the questions I ask myself. So right now, the question would be, why not have 100? Or why not have
right,
200? You would have them because they cost nothing. I mean, even if they're hand built, the cost is nothing compared to the reward. So the only reason you would limit the number that you have would be you're not ready to put them into
right.
testing
Or
or
yeah,
into learning or into actually working on the floor. So it could be 25, it could be 250, it could be who knows, but it would not be limited by money or by the difficulty of assembling them by hand.
right, right. And it might just be that you know, maybe there is some limiting factor. There's a couple motors that are just really hard to build right now by hand. You know,
Right.
it just takes them a couple of days or something like that. Because you know, think about it. For each bot, you have to have 12 actuators. They get the yes, so yeah, because the thumb does have two. So you've got 12 of those motors you need for each one of them. And maybe for some reason it's a bit challenging to crank those things out in the numbers that you need. So there are a lot of motors for each bot. So you could imagine, maybe that's limiting their volume to one or two a week or something like that. So it's taking a little while until they get ready to actually scale up the production. So it sounds like they're doing manufacturing in Palo Alto, and we know that because of the job openings that Herbert broke that yesterday. That you know, if you go to Tesla and you look for a Tesla bot, the number of job openings, I think there's something like maybe up to 52
52,
openings for various
52.
positions for a
Yes.
Tesla bot. Most of them are in Palo Alto, and you know, for testing and technicians and other things to help with the manufacturing. So there sounds like they're doing some production there, but there is one position that's opened up for Sparks. And remember, we had already speculated that Sparks could be where the production is, but they're not producing them there now. What they're doing is they're thinking about, we're going to start ramping up. And that means you need to bring in the person who's going to start to put that line together.
Yes.
And so that's, you know, 12, 18-month project or something like that before maybe they get it up and running, maybe quicker because it's not going to be like a car line. They already have the building, they already have the space. It's just going to be getting some of the equipment, doing some simulations, hiring some people, getting vendors to supply stuff. And we don't need any gigapress. So it's not like, we're building this line and we're going to need a 9,000 ton gigapress.
Right.
And
Right.
you know, that's on back order for 5 years or something like that. No, no, no. Most of that stuff they probably would be able to get in there pretty quickly.
And
And you
this
wouldn't even notice it arriving. You know, the equipment is just in the back of a normal truck.
and this guy specifically or gal that they want to hire,
Hmm.
the position is specifically to set up the line and
Set it up. Right.
and to set up the product chain, the materials, etc.
Right.
That's what the specific job is. And I would agree with you. Setting up that line, in my experience, I mean, you've had a lot of experience setting up these lines, and I've had as well. I think you're looking at a minimum of 9 months. Could take 18. I'd be surprised with the speed that Tesla does things. But maybe a year would be a nice number. So maybe by the middle of next year, they would be capable of starting to produce these.
Yes. Yes. Now, so this is the job description. Do you want me to put it up on the screen? I can try to share it.
Sure, you can. Oh, I have to give you that opportunity first.
Yep. It
I
give me
just
the
did.
opportunity, and I'm
Just
going to
did.
look around where all my controls suddenly went. Should be around here somewhere. Oh, there we are.
I haven't given you the
Yeah,
opportunity.
there we go. So let's go
There
ahead
we
and
go.
I'm going
All right, now you have the opportunity. Now you can share.
okay. So I'm going to go ahead and bring this up, share, and there we are. So this here,
There we go.
manufacturing engineering line lead Tesla bot. If you take that out, you would have no idea that it has anything to do with the Tesla bot.
Right.
So pretty much what you need to do, you know, determine the layout of the production line. That's the first thing you do with any line. You got to figure out the material flow and the operational efficiencies.
Right.
Determine procure equipment as necessary from all manufacturers. So you're going to start talking to your vendors. Work with equipment integrators to design, manufacture equipment and fixtures for medium to high volume production. So that means you got to get out there, start talking to the tooling design guys to start coming up with the stuff that you're going to need, which is custom and unique. And depending on, again, it looks like they want to go to high volume at some point. Manage suppliers during the specification, of course, that's, we expect that. Characterize and validate new equipment and the fixtures for introduction to the production floor, of course. Lead development of new manufacturing processes. There's potential there's going to be, I don't see it there's going to be anything like newly revolutionary like the gigacasting, but you never know. Lead development, manufacturing equipment and fixtures support early stage prototype builds. Okay, so they want to get that up and going. Perform process analysis. And so what we have is DOE, which is like design of experiments. Where you want to go through and start seeing, if you run these different scenarios, what's the best configuration you're going to have for things like line balancing and capacity. Provide design for manufacturing input. So what do we need to change in the design of the bot to make it easier to manufacture? And then obviously document all these things. And of course the expectation up here is a typical thing. It's like the machine to build the machine. You're going to cross-functional teams. This is what Joe Justice talks about all the time. This flat hierarchy where everyone is in the same room together.
Yeah.
So everyone's going to be there talking about what they have to do to come up with it. So again, you take the Tesla bot out of it. Seems like it's just a normal job opening for some sort of manufacturing line at Tesla. And then there were a lot of other openings that were in there as well.
And again, you and I both have the experience. If you're looking for this kind of automation equipment, you're looking for some maybe stationary robots and whatnot. If you get this guy on board, you get him into these design rooms for a while. Maybe it takes him 30 to 60 days to come up to speed because he's already going to be an experienced guy. You're not going to be hiring somebody who's never done this before. So maybe 30 to 60 days from now, he's up to speed. He's already talking to some vendors. And again, shouldn't take more than, I would think, 9 months to a year before he's 100% ready to go to start. That's not for prototyping. That would be the full online. The prototyping.
That's the full production, right? So it might mean that we're looking at the possibility of definitely a couple hundred robots by the end of this year.
Right.
And then, maybe in the order of 1,000 by the end of next year. And then after that, then the ramp up could happen that you start talking about tens of.
All right. So you are, so now we have robots in the factory doing some kind of task, but then there was some additional information that Dots got, which was the next level task. So what was that all about?
Okay, so we know there's many bots. Some are on the floor. Most are in the R&D. They said that it's like a little freaky seeing them walking around at night, right? And that they're already doing simple jobs in Fremont. Okay, so that's not in the R&D center. So that means it's been confirmed that in Fremont they are doing some simple jobs. And what are those simple jobs? More than likely, it's sort of what we talked about, the low-hanging fruit, some sort of picking and placing. And that part of what was mentioned is that they're aiming to make sure that the bots are able to tell when the parts need to be resupplied.
Right.
So that's like the next. So right now they're probably able to pick out of these bins, and then when the bin runs dry, the bot's not quite sure what to do. So now they're trying to do the next thing. So they're probably doing some sort of feeding of products. Very, very simple task in that way. In a lot of cases, if you're feeding parts, at some point you run out of parts because they're coming from someplace. Yeah. And usually you're in a tote of some sort that has the parts in there, a tray of parts, and you're pulling those things out. Now, in some cases, it might be that you have a conveyor that's kind of like, always bringing them in for you, and then you pull them off, and as soon as it's empty, the conveyor automatically knows what to do. But usually in these manual stations, it's not that way. You have one of these gravity feeders, which are gravity conveyors. So they're just basically a roller conveyor that's angled a little bit. And all someone does is they take a plastic tote that's filled with parts, and they fill it from behind. Someone comes in, puts it in there, and it kind of goes down, and then it stops. And then you might have 3 or 4 of these sort of set up that you pull something from here and something from there. to go ahead and put the parts in that you need to do, and then have whatever the process is, and then maybe unload it and put it off somewhere else. So the supplies of those are going to run out at some point. And of course, the first thing is the parts might be kind of jumbled in there. So you have to be good enough to be able to identify where they are, which part you want to get, and pull it out, make sure it's got the right orientation before you drop it into order you have. So that's, I mean, well, it's simple for us. For a bot that's already going to be a bit complicated, because you got to, find your target, make sure you get it right, and put it on down there. But eventually that tote gets empty, and what do you do next? Well, usually they have a second gravity feed conveyor that goes the opposite direction. So you've got your feed conveyor like this, and you've got another one underneath it that goes out the other way. You take the empty tote, you go on down there, whoop, you put it there, and whoop, it slides out. And so what that means is that you're on the side that you are taking the parts and then feeding your machine. And on the back side of that, someone comes along and is feeding it with full boxes when needed. So I suspect if that's what they're talking about, it's some task like that. Normally what happens is if you got someone going around with, they usually call it a milk run. So you have like a little train or something like that that's got all these parts on it, and it just kind of drives right on up and it's like, here's your delivery, and just starts taking out all the different totes to make sure you're full. And usually they'll make sure there's maybe enough for a shift or something like that, or for a half shift, so that as you start taking those totes out, you don't run out before the next supply comes in there. So usually they'll make sure there's 2 or 3 or 4, so you're not somehow all of a sudden short of parts. But again, you've got to make sure, take that tote, get it on down, go. And so now I guess the bot has to be able to go, hey, it's empty.
Right.
Well,
right.
Take it up, do this task. And usually that's one of those things that causes like your cycle time to briefly slow, because it's like, yep, throwing a part in here, throwing a part in here. So you're kind of going along there, and suddenly it's like, oh, wait a minute, one more step, things slows down for a second, now pick up the pace again. So that's the suspicion, is that something like that is going on, that the bot is trying to figure out.
Right. So that's a slightly more complex task, is identifying that you're empty, and then you're going to grab a hold of the empty bin, discard the empty bin, grab the full bin, whether that's on the floor, whether that's on rollers, wherever it is, whether it's a box or a plastic bin, or however it's coming. You're identifying, so the robot has to identify, visualize what's going on, make the decision, and then accomplish the next task. Now, I think this is an interesting place to insert that there was an argument, a big argument or discussion among the lab people, where, these guys are trying to do fun stuff, clever stuff, dramatic stuff. And so they had this back and forth about whether they should continue with these work-related things, or, so I'll let you take over.
Yeah, that was, so there was, I think if I jotted down the notes right, a few months back, there was like a serious debate on whether to teach the bot to do gymnastic type of things. And I don't know if it was like really considering backflips or something like that, but maybe things with a little bit more dexterity, or things that would require a little bit more power. So clearly, there are those people that are saying, wait a minute, we've got these goals and these guidelines. And again, I think I've quipped before in the past, and when's the last time that, when you applied for a job, that doing backflips was part of the requirement? So it's not a requirement for doing on down there. But what it means is that they must have seen something. It's like, we are really close. It's like, all we have to do this, and we think it can. And if that's the case, then it's got way more capability than we saw, because, it kind of walks around like it's a little bit arthritic. It doesn't seem to be that confident, not even walking a mile per hour. So, okay, can barely walk a mile per hour. Now you're telling me they're thinking of doing backflips of the thing? Now, it wouldn't surprise me, because remember, the torque control was impressive, how rapidly they were able to come down south. We've seen that the motors have the power to be able to lift a grand piano and everything else.
Right.
And I've always felt, I've had these discussions with Gary Snyder, and it's sort of the same thing. It's like the 3 biggest motors are all in the buttocks area.
Yeah.
And for walking straight ahead, you almost don't need them.
Yeah.
And they're barely needed at all. It's like these others that you kind of need. So they have these really big motors that are there that you could almost argue you don't need if you wanted to minimize the degrees of freedom that you have for walking. So the 7-degree freedom robot, but you really only need maybe 3 or 4 degrees of freedom to walk straight. But to be able to turn and do other things, you need those other degrees of freedom. But you don't need them that much, yet they got these big honking motors there. And part of it is the reaction time that you need. It's not so much that you need to deliver a lot of power to do something. It's just that you need to accelerate really quickly
Right.
to sort of keep yourself from falling down or something like that. So it's a stability thing. Well, then someone kind of realized, like, yeah, but we got so much excess torque right there. It's like, let's put it into plaid mode.
Well,
And they're probably like realizing that we can do something like that. And maybe from their simulations, they probably run the simulations, and the simulations have come up and said that, hey, we can do a backflip. And now someone said, let's get the mats out and start trying it. It's like, no, stay focused,
Well, and they would have two motivations. First of all, they've got the cream of the crop in the robotics world right now working there, and these guys want to do fun stuff. I mean, it's not just they're and the second thing is it's the competitive urge. Everybody's saying, oh, Boston Dynamics can do this and Honda can do that, and all these other guys.
It could be. Yeah. Which is why we're out here, right, trying to run interference for these guys. It's like, you don't need to do backflips, you don't need to do parkour. It's not part of the job description. Don't worry about it. We get your backs on this one, And they're probably like, it doesn't matter. When I go home, I'm going to hear from my friends. It's like, Atlas can do backflips. Your robot can't. So they probably want to say, we want to show you can. Now, if they're doing that, in seriously considering it, it means that pelvic unlock, which we're already seeing in the walking, must really be getting better and better. But the other thing we haven't seen is the toe off, which you would need to be able to walk a little bit faster. Yeah. And I would think getting a pretty good toe off is going to be really important to do whatever gymnastics are talking about. If they're talking about backflips, if they're talking about just being able to do a cartwheel, or whatever you'd be doing, forward roll, I don't care, somersault, then you might need either a little bit better control or something that they would have to change the mechanics for that. And that could be part of the discussion. They might say, look, if it's just a software thing and a training thing, fine. But if you're talking about us changing the design of the ankle so we could do backflips, no, that's a non-starter, because the whole thing is you don't need to do the backflips. What we need to do is figure out how to get the robot to change the totes. That's more important. So let's focus on that.
So you are famous also. One of your famous statements that's been repeated and repeated is where you believe the genesis of the robot took place, where Elon finally made the decision, we need to make a humanoid robot in order to accomplish tasks like this. So back to your story of where you think that took place and what was revealed today that
that could be interesting. Now, everyone's always asked the question at some point. It's like, wow, if you had a chance to talk to Elon, what would be the one question you would ask him? And everyone sits there and they're like, oh, what are we going to do? What's going to be unique and everything else? And I think I finally know what it is, and that it's like, where did the idea of Optimus come from? Was it from reading, Isaac Asimov's Foundation trilogy when you were a kid? Did it kind of come along somewhere else? When you were a kid, you looked at that, did you say, oh, wow, in the future, we're going to have these things and I'll be able to buy one someday when I'm older? Or were you thinking, no one else is building one, I'm going to be the one to build it? That's what I kind of wonder. So I had a feeling the idea was in the back of his mind for a long time, and he knew someday they were going to do it. And probably the Model 3 ramp up was when he said, all right, we definitely need a humanoid robot, because they went from, it was going to be mostly manually assembled on the Model 3 to like the last minute, oh, we can automate all this stuff. So they said, let's automate everything. And then they were like, in for a dime, in for a dollar kind of thing. It's like, we're going to automate the whole thing. And it's like, and they'll tell you, no. It's like, you don't automate all of it. You automate the things that are easy to automate. And some of those, you try to automate them later. And so, Elon was spending his time on the shop floor, when he was sleeping out there, trying to figure out how to get this very flexible piece. I think it was a piece of insulation that was going in the underbody, and trying to program the robot. And they could never get it to work reliably. It would work sometime and it wouldn't work after that. And it just became a very frustrating experience. And of course, that's when he talks about how he got his 5 principles backwards, because they finally went back to find out that you actually didn't even need the part in the first place. So he wasted all his time trying to figure out how to do it. But then he learned that not only do we not need the part, but even if we did need the part, the robot can't put it in. It has to be done manually because it's a flexible piece.
Right.
And this was just like insulation. And almost anyone that's worked in factory automation could have told him right away, flexible, don't do it. These robots need a super structured environment. Keep it structured, keep it simple, and it will work fine. But if you have flexibility in there or anything like that, you're going to have these problems. So probably when he saw that, he was thinking about that. And of course, harnessing has also been something he's complaining about. I think there's some famous videos of them out there talking about the difficulty and what they need to do to try to come up with other ways of making the lines so they're very easy to automate in some way. So we know that's
wiring harness. The wiring harness.
The wiring harness. Anything with
takes the electricity from the battery someplace and then runs it through the car so it can run the taillights.
Right.
And that's how
exactly. And it is like the most manual of manual operations that you see on the final assembly line. That when they bring the dashboard assembly, and the next thing that happens is some guy's got to go in there and crawl. Some guy or gal, has got to go in there and start snapping all these things together to get them to fit in. And then you'll see these other areas of the wire harnessing having to get laid out, and they talk about, you think, oh, there must only be like 100 feet, or maybe 100 yards. Like, no, they literally talk about miles of this stuff that you have in a car. It's unbelievable how much that you need to be able to connect everything together. And to me, I still can't believe when they tell me, like, that'd be that much, really? So it's very manual. It's something that's been very difficult to automate this because of the flexibility, and it's just difficult to figure out how to snap two things together. Now, we already saw in that one video the ability for it to go over and kind of grab a wire that was part of a test stand. And a little bit, it wasn't quite clear whether it was already unsnapped, so it didn't have to do unsnapping, but it gave a little bit of a tug and was able to find it and do it. So we already know that they were thinking about that. And it sounds like they probably are a lot further along on that than what we just saw in that one video, that they are doing something with that, and that is so they are working on being able to deal with wiring.
So this was, again, connecting for those of you who might have been jumping around, connecting the dots. They made these revelations, and one of the revelations had to do with the fact that they are specifically working on getting the bot to be able to work with flexible wiring, not necessarily specifically being able to put a wiring harness in, but being able to work with the flexible
something that's flexible. Yep. And depending on how they're going to be running the wiring,
right?
Whether it's something that would be a two-man team or two-person team, three-person, or three-bot to be able to run these lines through whatever openings and access ways they have. And so that means they're no longer looking at the fruit that's on the ground. That was a low hanging fruit I was always talking about. Maybe they really are starting to get the fruit that maybe are like eye level or above, and going after that to come up with some more challenging tasks. And it sounds like they're very happy with the mechanics if they're already talking about wanting to do a little bit more or kind of get some of these capabilities out. They must have reasonable dexterity to be able to grasp things like a wire harness and finesse it the way they need to get it in a certain location. Now, the problem has always been the reason why the industrial robots are not good at this is because you really need a good vision system. If it's really as simple as that the parts are exactly where they're supposed to be at all times, you can come down, close your eyes, grab the thing, go in there, and then they snap in. And then you might be able to do something to feel whether you're getting the right force to kind of plug them in. But the problem with the flexibility is that things can misalign and things are just not exactly where you want them to be. So you would want some sort of vision system to allow you to see how they're lining up. And misalignments can be difficult. That not only do you have to make sure the placement is right, you have to make sure the angle is right. If you're coming down at the wrong angle, it's not going to slide in correctly as well. So you want to make sure you have all that, have good control of that, and that's where a vision system comes in. And my overall feeling has always been that if you can get a real-time vision system that is able to adaptively control the process, then you can do just about anything. It can be a flexible process. It can be a process where things are indefinite. It can almost be jigless, fixtureless kind of processes now, because you don't actually have to have it clamped down in the right place. It's just like, oh, just kind of put it down, now go over and do your particular process on there.
So Scott, you've got a lot of experience putting these kind of things together. You've got a lot of experience in robotics specifically, but in using robotics in other people's factories to help them become more effective and more efficient. That's what you've done for your entire career, something like that. So have you ever had a client, have you ever yourself in your own companies ever hired this lead position when you weren't ready to begin to build out your line within 12 to 18 months?
Oh,
And
no,
I
I mean,
don't mean,
yeah,
I don't mean a Boeing 747, but assuming a relatively simple, you don't hire this guy until you're ready to start buying
right,
the parts,
right,
buying the
right,
pieces.
right, yeah. And I think it's not like they're just saying, oh, there's an empty room, just, go ahead. They've already got some ideas, so they've been working with it. Now they're trying to find a person to actually implement the vision that they have.
Right.
So they've already got a lot of plans. Now they just need to bring on some expertise and to say that it's not going to be in Palo Alto. We've been maybe, looking at it in Palo Alto and what it should be like, what our expectations are, the square footage that we're going to need, and we've determined it's going to be over here in Sparks. Now we need the person that actually is going to run with the whole thing and start hiring a team that's going to be necessary. And this is going to be probably someone with a certain amount of experience as well. And of course, they're probably looking anywhere, not just someone that's from Sparks,
Oh yeah.
but someone that probably has experience and maybe is like, ready to pick up and go out to someplace new and work on a really exciting product.
And be part of maybe the biggest product since fire.
Yeah.
So, let's see. So I don't know what it takes. Gary Black and was on the Herbert's show earlier today. I guess they recorded it last night, but they did the Tesla bull thing and Gary says, hey, show me the numbers. I'm not going to put it in my numbers. I'm not going to put it in my projections. I'm not going to start thinking that Tesla bots are going to contribute to the bottom line until I can see numbers. What do you think he'll need more than the show today? I mean, what does he need to see? But I mean, Rivian was worth $100 billion when it was just a drawing.
Yeah. Yeah. Yeah, I can understand why, especially if you're running a fund, why you have to be so cautious. But if you were running your own fund, in other words, you're looking out at your own stuff, you can take that into consideration and sort of decide that. And certainly I can see the cost savings. We've been over this a few times, that we know for even very simple tasks, you can save a lot of money and save a lot of money very quickly. Now, everyone goes on, let's back off a little bit. Everyone keeps on saying like the value of the Tesla stock is all going to hinge on the margins. And everyone's all nervous for the 19th. Like, what are the margins going to be? Are they going to be more than 20% or less than 20% and everything else? And it's like, if you're so fixated on the margins, then you want to start thinking about how Tesla bot is going to affect those margins, not because they're selling it. That's not the whole point. The whole point is reducing the costs.
Yeah.
And we've already shown those spreadsheets, and we're not the only ones that do it. Other people look at it and say, wow, yeah, this costs a lot. So the amount of money that you can save. So you don't look at a worker, you have to look at an operation. So if you have an operation that's going to be 24/7, then you're really talking about you need to have 4 workers staffing that single operation.
Right.
So you're paying not for 1 worker, you're paying for 4 workers. And if you want to go down minimum wage or something like that, you're already talking about, or you're going to be at least $15 an hour, maybe more likely 25.
Right.
You're going to have all the other costs on top of that, FICA, 25% on top of that for everything else. So the hourly kind of goes up. And when you actually look at it, a worker will be costing you anywhere from $60,000 to $70,000 a year.
Plus.
Yes. So that not just their salary, that just for them. And then you got to worry about, safety equipment, a lot of the other things. So just that 1 worker. Now multiply that worker by 4. That's how much it costs you to do that. So when you're looking at the Shanghai video where that part is being placed in there, so I think about every minute or so, I think it might have been about a 45-second cycle time, and there was like 4 parts that are being placed in there. So maybe within a minute, about 6 parts are being moved through there. And so you can then figure out how many are you doing per hour that way and how much you're paying them. So how much does that process of that worker just picking up the part and putting it over there cost you? and you're gonna be looking at that, it's costing you like maybe 10 or 15 cents. In some cases, maybe 25 cents for each part. That operation alone, that's the value add on that one.
Right.
Just that one part.
Yeah.
And then you keep on going on there. So you look at it, it's like, they keep adding up and adding up and adding up. So if you can eliminate that one worker, you're saving $250,000 right there.
Yep.
And then you start multiplying that by lots of them.
That's
a lot of savings. And that goes to the bottom line, and that goes straight to margins.
Yeah.
And that's the calculation that I think people in Wall Street should be doing with Optimus. If they want to talk about Tesla as chum, them selling it and stuff like that, this kind of pie in the sky, I could understand them saying, no, we're not ready to do that and talk about the fact that it's going to be worth more than all, automotive, energy, storage, all that combined is going to be 10x that, because that's, Elon has basically says that's what he thinks. I can understand Wall Street says, no, we don't, we're evaluating. We just sort of figured out that Tesla might not be a car company. It might have some other things in here, but we're not willing to say what is a Tesla bot worth external to Tesla. Okay, fine. Really make the calculation. How does it affect the margins?
Yes. Now that might be in their expectation. Tesla might have, part of their statement that they would save 25% on the Gen 3 car might have been taking into consideration the Tesla bot being, because they've said that there will be Tesla bots, working in Mexico. So this could easily be part of the calculation.
And it may be that it's going to be sort of contentious when the bots are going in, because are you eliminating jobs? Are you firing people, or is it just going to be kind of through attrition? Or part of it's going to be that, no, we're going to ramp up. We're going to from 3 shifts to 4 shifts now. We're just going to be kind of moving people around, and we're going to fill that basically with the Tesla bot. Well, so that may be one way of doing it without actually resulting in having to fire people. In Mexico, it's a little bit easier because you don't have people to fire yet.
Automation is always contentious. I still say that email resulted in the firings of more people than any other product that's ever been invented.
Oh yeah, and word processing for sure. I mean, it's like, within our university, I remember there was always this big typing pool of all these sectors that for typing all kinds of things. And whenever you had a research, when you ever had a research paper or something like that, you came up, and of course there was like this cottage industry around the university from all these students that needed to have their research papers typed. That you went off somewhere else, and there was this woman that just had an IBM Selectric, and that's what she did all day. She was just a really good typist. Yeah, and that was very big. And then as soon as computers came out and you had Word, now suddenly everyone was a typist. That was gone overnight. And where I went to school in Cornell, just up the road was Cortland, and there was a little company there called Smith Corona. Yeah. And I remember always like driving by there on the way, and it's like this big thing, like all these jobs that were there, because it was a company town. They were very proud of Smith Corona. Yeah. And it was just, it was there forever. It was always going to be there forever. And not too far up the road from me was Rochester, New York, and a little company called Kodak. Yeah. And then the next to them was another company called Xerox. And just down the road from us is Corning. They seem to be doing pretty well thanks to the iPhone, by the way. But the others, I mean, technology came in and it shifted all that thing. In Smith Corona, they did not shift along with it. Kodak famously did shift along with it. And of course, a lot of those, but then it started to bring in other jobs, web designers and everything else. Right. And I know this is what everyone keeps on saying, like, but Optimus is like those jobs that you have in the automotive companies are very good paying jobs. And you know why they're good paying jobs? If you think about it, just about everyone, about 30% of your income goes to transportation, which usually means buying and maintaining a car. Right. In some cases, for a lot of people, it'll be a lot more than that, but I think the average is somewhere around 30%. And then on top of that, you start thinking, well, then you're going to have housing on top of that as well. And then some medical, there's not a whole lot left over. And so what we're saying is that, well, now, such an important part of our economy clearly is centered around that we're talking about it might just suddenly disappear or not be there. And it's like, well, we've done that before. We've actually fired 90% of the workforce.
Right.
They were called farmers.
Farmers, yes.
And if you go back to when you had a farming economy, we didn't have a whole lot of other things. I mean, most of the time was spent in just producing the food. There's very little time to produce other things. So a lot of heirlooms would be like someone's coat because you didn't have a whole lot of clothing. It was very expensive.
Right.
And families fought over who got granddad's coat, who got the kettle. I mean, kettles were things that were also written down in wills on who was going to get pots and pans and things like that, because there was like no time to do anything else except farm.
Right.
And so suddenly, when we did not need to have 90 or 95% of the population doing farming, they were able to start to do other things, which now meant, of course, around the same time in the Industrial Revolution, you have power looms and stuff like that. Now suddenly clothing becomes more plentiful, and you don't just have one jacket that you have your whole life. You can now start having multiple things. You can start having all these other nice gadgets and stuff.
Sure.
But right now, we all know we have to have transportation. We know we have to have a car, but it costs so much. That's why it's there. And if you ask the workers, what do they want to have? A good paying job or working in a factory? I just want a good paying job. I don't care if I'm working in an automotive factory. If you can give me the same good paying job that isn't in there, yeah, there may be some that kind of like it because they somehow like the smell and the feel and everything else and the buzz. But most of them, they're there because it's a good paying job, not because that's where they want to work.
Yeah.
But now, if you can start saying the economy is going to open up, we're going to start creating these new industries we never thought of. And that's where the workers are going to go. And rather than paying 30% of our income, transportation, it's going to get smaller and smaller and smaller with a lot of things. And now you have this age of plenty where a lot of things can be done and people can be very, very creative with their time. Because we've already seen that's what happened in the Industrial Revolution. It was painful.
Every single time. Yep.
Yes, every single time. So it was disruptive. Yes, you had the Luddites, you had a lot, it was a painful transition, but it was one that inevitably is going to happen. And as a result, people were able to live much better, more fulfilling lives, longer lives, and everything else. And the same is going to happen here. But yeah, we know it's going to be disruptive. There's no doubt about that. But I think in the end, every generation has had to make a sacrifice for the next generation. We talk about the greatest generation and the sacrifices they made so we could have the freedoms, everything else we have. So it's like, okay, we're going to have to maybe make also sort of the similar kind of sacrifices so the next generation is better off than we are.
Yeah. Whenever you have more efficiency, you always have more wealth. That's the short way of saying it. So, Scott, thank you for coming on and sharing with us. I hope you and the audience, this is not investment advice. Neither of us are investment advisors, but this is, according to Elon Musk, not according to Randy Kirk or Scott Walter, this is the most important invention probably since the wheel and fire. There is an unlimited TAM. The margins on it are so huge that it breaks the economy. So you build it for $6,000 to $10,000 and you lease it out for $50,000 a year. And the person getting that lease from you is thrilled to pay the $50,000 a year because he's replacing $250,000 a year. It breaks the economy. So this is not a simple brand new car or a brand new way of cooking something or no, this is something that's going to break the economy. You in this audience right now are on the bleeding edge of something that is going to change everything. And we're enjoying chronicling it. It's really crazy to think that we're a part of this massive, massive change that's going to take place. Scott, again, thank you for joining me today. Hit the like button. We know you like having Scott on. That's not even a question anymore. And hit subscribe and notify. And if you want to see a lot more of what Tesla is doing, there's always this book, something called the Elon Musk Mission. And then Scott, any last thought?
Right back there somewhere, I think.
Right there on your shelf. Look at that. All right.
Yeah, it's on the Elon.
Did you read it?
Now you got to get more lights in here, otherwise Brian White's going to end up on here more than me. So
I just need you to call me when you've got something great. I'll have you on 5 times a week if you've got something to talk about. Trust me.
But Brian's he's a font of information. I enjoy listening to him. He's also entertaining, but he's also got a lot of information.
All of that is absolutely true. Okay, so thanks again, Scott, and to all of you out there, thank you for listening.